Hi, everyone. How you all doing? Fine? I appreciate that quick response. Sleepy, too early in the morning, hungry, too late for lunch. So hopefully you come for this talk. If not, you're probably in the wrong room. So I'm going to give you 5 seconds to leave. And after that, no one can leave, okay? I'm kidding, you can leave. All right, so let's begin. So we're here to talk about why data science and UX research should be best friends. But before we dive deep into this topic, I have a question for you. How much amount of data do you think exists in the entire digital universe? Shout out some answers. It's okay if we're wrong. Yes? 20 billion, okay. Is there quantifiable, as in you want to say gigabytes, petabytes? Petabytes, okay. 20 billion petabytes. Okay, cool. Okay, gigabytes, petabytes, all right. Any other answers? Come on, you can do better. You're developers. Don't we have to estimate things all the time? But not let anyone know that we're estimating it? All right, the correct answer is 97 zettabytes. They actually had to come up with a new unit called zettabytes to be able to quantify this amount of data. And 1 zettabyte is 1 trillion gigabytes. So we're talking about that many zeros. I'm not going to count, but feel free to. Out of that, 80% of the data is unstructured. That means it doesn't reside in your normal relational databases, right? It could be audio, it could be video, it could be documents, it could be a bunch of different things. Surprisingly, only 2% of that entire data that we saw on the previous slide is saved or retained next year, which means we're either consuming or overwriting 98% of the data that gets collected. So, how confident are you that your companies and your teams are utilizing data to the best of their abilities? And don't worry if you feel not, we'll go through this together. So hi, I'm Grishma Jena, and today I'm going to be talking about data science and user research. I work as a data scientist with IBM in software, IBM software in San Francisco. Love doing public speaking, one of the reasons I'm here, and especially love encouraging people in the world of technology with a focus on women and youngsters as well. These are ways to contact me if you have any questions later on. But let's dive right into it. So how many people here are familiar with UX research or user research? OK, about half the room or maybe a little more. All right. Example one of a fail. You don't matter, give up. Clearly, this person did not think about the ordering that it's pasted in. So if you have UX fails, if you have bad user experiences, it could be dangerous. Example two, don't turn off the light switch. It also operates the elevator. Bad user experience can be confusing and, again, dangerous, only for the people in the elevator. Example number three. What is this? Any guesses? It's cake. It's a cake shaped like dog for a kid's birthday party that's made of red velvet and has red velvet icing. So this cake was cut, and all the kids thought that the dog had been murdered, and they had to eat that dog. Chaos all around. Bad user experience. Last but not the least, anyone over here seen the Barbie movie, the latest one with Margot Robbie? Yeah? So I had this experience just a month ago. I was very excited to see this movie, and it was a group of 4 of us. I had some two coupons, which gave me free tickets, and then 2 other friends of mine had to purchase their tickets. So we went in, we tried to apply the coupon codes in the system and get 4 tickets. And suddenly we noticed that the screen said printing 1 out of 6 tickets. And it gave us these 6 slips of paper. We got really confused, and we thought maybe we got 4 plus 2, the free tickets. So we go in, we ask for customer service, and this is a late night show, though, so we have to really hunt for customer service, and we are missing the start of the movie. Customer service comes in, she sees what's happened. What happened was it actually didn't print 6 tickets, it printed 4 tickets with 2 receipts. Why would a software say it's printing 6 tickets if there are 4 tickets and 2 receipts? Confusing, right? Customer service sees that this is wrong. She says, okay, I'll try to help you out. She applies a charge for customer service. So we ended up paying extra because of that UX fail. She then looks at our coupons and does something weird, in which case the coupons also get cancelled out. So we ended up paying extra. And then finally, when she realizes her mistake, and by this time the refund and transaction, all the processing is happening, she says that there's an extra charge for all of the transactions to be reversed. So we ended up paying for double the amount of tickets at the end, which had me feeling like this. Well, technically, it was my friend who paid, so he's the one figuring out the issue, so I think he's the one feeling like this. But that just goes to show that bad user experience, bad customer service, you are just going to be frustrated, and you're probably going to think twice before engaging with that company or with that product or using that software. Which is why UX, or user experience, is really, really important. And now some of you developers might be thinking, well, this isn't our job. We are responsible for coding, making sure the applications are bug-free. But it's really important for your users to be able to use your app successfully. Otherwise, they're not going to return. They're going to go off to a competitor. Think about an iPhone, right? It's known for its design, its good user experience, and that's why it's actually a very successful product. Now, there's often a misconception between UI, which is user interface, and UX, which is user experience. UI talks more about the visual elements that you see. You have your screens, pages, buttons. UX, however, focuses more on the end-to-end interaction. The user is logging in. Are they having troubles with finding documentation? Do they have to open a support ticket because there's a bug in the issue? Or are they able to successfully complete the task that they came for? So that end-to-end journey is user experience. User research, or user experience research, specifically is a very methodical study of how that end-to-end experience looks like. What are the needs for the users? Why do they come to your product in the first place? What are they trying to accomplish? Are they successful? Are they successful with maybe a few blocks in the way? Or are they completely frustrated and giving up and going to your competitors? This is what user researchers generally do. They apply what's called design thinking. Design thinking means at the center of the framework is your users. We heard in the keynote today, right? Users are important. Care about your users, what they want. They don't really care about your infrastructure. They just want to be able to do what they came here to do. Try to understand what is the intent behind their visit. What exactly is the problem that your product is solving, and what are the outcomes you can develop with that? So user research consists of doing something called an empathy map, where you try to create how the user feels, how the user thinks, what is the user trying to do. So you try to empathize with the user by placing yourself in the user's shoes. You, of course, try to gather feedbacks. Are there any questions the users have? Are we making any assumptions? What does that look like? You try to create an as-is, which is the current scenario, and then a to-be, which is the future idealistic scenario that you want to go towards. And last but not the least, you create need statements, very similar to user stories, right? What does a user need to do? Why do they need to do it? How are they going to accomplish it? And what is that wow factor that your product is going to develop? Is it going to save them multiple hours? Is it going to be cost-effective? Is it going to do something in an automated fashion? What is that wow factor? So this entire journey of trying to use these methods and talking to users, doing interviews with them, collecting surveys, that's what user research entails. This is what the pipeline looks like. You start off with interviews, observations, surveys, go through the analysis. Maybe from the analysis, you realize that certain designs need to be updated or certain things are not clear. You can create a prototype, test it out with users. Maybe there's some more changes to be incorporated. And then finally, when the users are happy and the goal is accomplished, you can push it into production. And of course, this is a cyclical process. It could be generative, which means you want to understand if you're building the right thing. Or it could be evaluative, which means the current existing thing that you have. Is that right? Is that well made? Does something need to change? And these are the type of methods that user research employs. Ultimately, you want certain insights into why your users come to your product, what exactly are they looking for, and how that's going to affect the bottom line of your product, right? That's what companies care about. We want to earn money. We want to keep hold of our customers. We want to reduce the attrition rates. And at the end of the day, we want happy customers. All right, so that is the user research side of things. Let's switch gears and go into the data side of things. How many of us have faced this scenario before? I think we should probably replace big data with AI now, right? Because all the companies are like, yes, AI. Like, how do you incorporate AI? We don't know, but Gen AI. So for the purposes of this talk, or even generally, data is any piece of information that can be manipulated, that can be stored, that can be processed. Data science specifically are certain methods, certain heuristics that you use to make sense of that data. What is this data collected? What does it mean? What is the general aggregate level of the data telling us? And machine learning specifically is having the computers, having our programs look at that massive amounts of data and understand if there are certain patterns that exist without us explicitly telling, hey, there's a pattern over here. At the end of the day, data is the language that your customers are using to speak to you, whether that's an angry support call, a frustrated support ticket, an unhappy feedback survey, or just a neutral user interview where they weren't too impressed with your product, right? You are doing something to their experience, something good, something bad, and data is the way you can actually measure that. And that's them speaking to you, if it's working or not. So, how can data science help user research, or ultimately help make better, useful products that make people happier? You can detect user struggles. Maybe you're noticing that a particular user is really having struggles with a particular web page. They're trying to refresh the page or click buttons that are not working. Maybe there are certain hypotheses that you want to test out, looking at different groups of users. User segmentation, another one, right? Maybe you have daily users, and then you have users that come probably once a quarter. So you would want to treat them differently. How do you analyze the usage patterns, right? Which again goes back to user segmentation. Perhaps you also want to do some sort of prediction. Can you predict how many users, how many new users you're going to get in the next quarter? Or can you predict who is an unhappy user and is actually considering terminating their contract? Maybe you have a bunch of features and you want to evaluate and understand which is the most important feature to our users. Maybe you have multiple data sources that you want to combine. And of course, personalizing the experience of the user as well. So this is what a data science pipeline looks like. We start off with the question and the data. We then go through the processes of wrangling, cleaning, exploring, modeling, pre-processing. There's a little bit of a loop over here. And then hopefully you want to end with validation and telling a story which will lead to actionable insights. And if this doesn't make sense, no worries. We're going to dive deeper into this right now. You want to start off with a question that you or your stakeholders are interested in. Who are the next 1,000 customers that are going to leave our platform and why? Can we predict click probabilities on our platform, or how likely a user is to buy a different product of ours? You then hopefully have some data at hand, and it's completely okay to start the other way around as well. You have data, and then you want to think questions that you can answer, or you have a question, and then you try to hunt the data that can help you answer that question. So that data could be structured, which is your relational databases, right, with your rows, columns, tabular format. You have unstructured, like audios, videos, and then you have somewhere in between semi-structured, where you have some property that you exist, but then within those fields, it could be unknowns. Kind of like an email attachment, right? You know what the subject is, what the sender is, but within the email, it could be a text file, it could be an audio, maybe even a virus, right? So that's semi-structured. So once you have the question and the data in place, you're going to go through the process of wrangling and cleaning the data, which means you have to gather the data, you have to select and see what columns make sense, what are the most useful ones, transform that data. Oftentimes, there are different formats that the data exists in, so you want to make sure that all's standardized. And ultimately, you're doing that so that analysis as well as access is easier. So I really like to give this Marie Kondo example. Clean data sparks joy, and unclean data just does not spark joy. Next comes data exploration. Think of this as getting your feet wet with the data. We're just doing some very initial sort of superficial investigation. You're trying to understand if there are any interesting patterns that appear, perhaps have some hypotheses that you want to test out, or maybe something looks really, really surprising in the data that you weren't expecting. Next comes model building. And yes, this is an actual example of machine learning models being trained to identify if the given image is that of a dog or a muffin. So that's where all billions of dollars are getting spent. Very important, though. So what this does is where we create models using the features, the data exploration that we've done in the previous stage, right? Hopefully that's given us some information. And we divide this into training and testing. Very similar to how we as humans learn, right? We learn concepts in the classroom, and then we probably give an exam on that. So that's the testing phase of it. And depending on your problem statement or your objective, there are different types of models that you can select. You want to do model evaluation because you want to make sure that your models are performing as well as you expected. So there are certain metrics like accuracy and precision that you use to understand if your model's performing well or not. Hopefully, you're happy with the model performance. Now you want to tell a story. If you're going to go up to your stakeholders and say, hey, I built this model, it has amazing performance, it has 99.2 accuracy, it's great, amazing, just, let's go ahead. They're not going to understand anything. They're going to be like, okay, but are you able to predict if our customers are going to stay with us? Are you able to understand who are the new customers we should target? That's what they're interested in, right? How does your work connect to the business problem that you're trying to solve? This is where data visualization and data storytelling is really important. Earlier on, we used to have dashboards and reports and this whole concept of data exploration, where the user was expected to spend hours, weeks, getting trained on that, understanding how the dashboard looks, how to generate that reports. It took weeks and months, and it was really a frustrating experience because you can't get to the information fast enough. The new way of doing this, though, is data storytelling, which says, communicate to me like a human. Don't just show me random numbers. Give me that story that I can identify with, right? I want something that's personalized to my needs, and I want the information right now and only the information that's relevant. Which is why, stories are really powerful because we remember them, we can relate to them, we can associate with them. And this is exactly the technique that's employed when talking to your stakeholders as well. So we talked about user research. We talked about data science. If you look at data science, it's more on the quantitative aspect of it, where you're trying to deal with numbers. You're looking at maybe multiple users at the aggregate level. And then on the other side is user research, which is more qualitative in nature, because you're talking to users one-on-one. You're trying to see why they are feeling that particular way. How are they trying to do something? But data science is focusing on the what, right? What exactly is happening with the users? For example, let's assume I put out here a huge box of free ice creams, like the ones there, right, back in. Me counting how many people are actually taking that free ice cream, that's quantitative for you. On the other hand, if I come to you and I ask, hey, how does free ice cream make you feel? Are you excited? Probably most of you would say that. Are you scared? Because why in the hell would somebody order free ice cream? There should be some strings attached to it. So maybe you're nervous, you're scared, you're wondering what's going on, confused. So that on the other end is user research. And this over here, me counting how many are actually taking the free ice cream, is data science. So hopefully that gives you a little more clarity on the different ends of the spectrum. All right, now what happens if we combine the two? Any Captain Planet fans here? Yep, let our powers combine. Airbnb is a great company that does this. It does a really good job of having their data science and user research teams work in conjunction with each other. So here's one case study where they actually looked at data to understand host preferences. Data scientists working understood that there were actually differences between a host accepting a booking or not accepting a booking, depending on what city they were located in. Usually people in bigger, busier, more expensive cities wanted longer periods of renting, and they did not want to have a lot of gaps between them. The hosts in smaller suburban cities, though, they were okay with having short-term rentals or just for a few days and having really long breaks. That was an interesting analysis because now the system would be able to understand and show only the bookings that the host would be likely to accept to the user. So that's where the user experience part is coming in. We can make lots of hypotheses. Maybe the people who are in big cities are going away for a long period of time and want to get as much money back because expensive rents. Maybe the ones in smaller cities have a room in their own house that's being hosted, so they're perhaps okay with it being empty. A bunch of hypotheses can be made. Second one, very interesting. If you can see this image as the background, very faint, but hopefully you should be able to see it. This was Airbnb's design landing page way, way back when they weren't really known. Interestingly, a data scientist was reviewing the data and realized that people from certain Asian countries had an extremely high bounce rate compared to the general population. The data scientist goes to the engineering and design team and says, hey, any idea what's happening? This looks really peculiar. And the team figured out that something was an issue. They did like a check of their engineering systems, the infrastructures, no bugs, everything was fine. It was just very strange user behavior. The teams got together and they redesigned this page. So this page initially would actually show you photos of the neighborhood. And what happened with these bouncing users was that they would click in that neighborhood, look at photos, like maybe 10, 20 of them, and then completely abandon the booking, forget about it, and log off. Instead, the new version of that page replaced that neighborhood link with the top popular destinations in that particular country. And believe it or not, that led to a 10% increase in conversion. Just that one change. So that's a great example of how interdisciplinary teams like user research, engineering, and design, and of course data science come together to actually create a really, really beautiful experience. Another case study was that Airbnb wanted to show the popular destinations or the popular neighborhoods to people that were renting, right? Because most likely they are tourists, they want to stay close to a neighborhood where there is a lot of nightlife, good restaurants, probably a lot of sightseeing to do. But instead of asking the users or having humans manually tag the data sets like, okay, this neighborhood is really, really popular in this particular city, what they did was they started looking at the user search data because the users themselves were saying, so in San Francisco, Mission District is really popular. It has a lot of nightlife. And then they used all of that data to skew the search results. Because they know that people who are looking for a place in San Francisco generally want something in the Mission District. So let us just show search results at the top that are Mission District. So that is another interesting use case where they actually had the users and the data that they were creating become the weights and the tags for the models that they created. Okay, so far I've been talking about how data science is great and user research is awesome. But let's go into this next case study with AB and Abro, which tried to create a machine learning model that could help case support agents quickly understand what tags to associate with a particular support ticket. Pretty general case, sounds like it's going to be successful. They did the metrics, they did the evaluation, the accuracy was somewhere like 95%, super happy, everything looked great. User research team was also excited because yes, our support agents, we've verified that our support agents need help. They do take too long to manually tag and think of the tags, right? Everything looks great on paper. This model goes into production. Absolute disaster. The times taken by the support agent increased, doubled, tripled. What was going on? Support agents wanted this feature. Metrics were looking good. Everything was behaving as expected, except the users, the support agents were not happy. They were actually taking longer. When user research stepped in and actually went to talk to these users about what was happening with these models that they were using, they realized that this machine learning system was actually giving a list of 20, 30, 40, 50 tags to the customer support agents. And now the customer support agents, instead of automatically thinking what tags could be applicable, was scrolling and scrolling and scrolling endlessly, increasing the time they were taking to complete that task. So user research went back to data science with this feedback and said, hey, there are way too many tags. It's taking too long. And then the team said, OK, we're going to restrict. We're maybe going to show only the top 5 or 10 relevant tags. And then they made that change, and then it was a success. Again, goes to show why talking to your users is really important. Because even though things might look right on paper, that might not be the case in reality. An interesting thing that Google did back in 2016, 17, if I recollect right, was they actually used deep learning models to understand if a particular interface was usable or not. So as you can imagine, doing user testing, right, actually recruiting users, talking to them, seeing how they use the product can often be time-consuming and expensive. So Google said, OK, can we automate this process? And they fed in data from humans that had used their products previously. They created a deep learning model out of that. And that deep learning model was actually able to predict if particular elements on a web page were tabbable or not with more than 90% accuracy. So very, very similar to human accuracy. The kind of input they gave it was, what is the size of this button? What is the color of this link? Where exactly is this on the web page? And the model actually did a really good job. So this was a very interesting case study of user research, but in an automated fashion using data science. Let us see if the sound can play. I guess not. Any guesses what the song is? Yes, it is Sorry from Justin Bieber. Spotify had this ad back in 2016 where they said, dear person who played Sorry 42 times on Valentine's Day, what's wrong with you? Are you okay? Do you need help? So this is kind of an interesting use case of marketing using, data science and user research. Anyway, Spotify is also another good company that really combines their data science and user research teams together. So what they did was, this was back, I think, when Spotify Premium wasn't widely available. It was still a pilot test going on. And this happened back in Australia, so it was Spotify Australia doing this. There were certain power users that the teams had identified, the ones who really knew how to use the platform and were doing it very well. And what they did was they noticed that all except one particular power user seemed to be hitting some sort of a limit when skipping ads, right? This person would just skip 6 ads and then just like, that's it, it would flatten out. They went to their engineering team, debugged it, investigated, everything was fine. That was confusing. So then they called their user research team and said, hey, can you maybe do something to understand why this is happening, what's going on? The user researchers were like, yeah, we can do a diary study, which basically means that you ask the users to keep like a journal or a diary and record their experiences over a period of, a week or 2. So they went to this user, they were like, okay, can you tell us what's happening, because you're a power user? And then they realized that this user actually thought that they couldn't skip unlimited ads, which was the feature of Spotify Premium, right? You can skip unlimited ads. They thought that they could only skip 6 ads because they were allowed only 6 song skips. So this user had mistakenly believed that because they could only skip 6 songs, they could also only skip 6 ads, which is why they were not even attempting to do that. So this was a case of anomaly detection, right? Because this user had a very anomalous behavior, where data science team figured out that something was going on. User research team went and understand why is this happening, the qualitative side of it, and then came back and reported. So obviously their messaging and their communication had to be changed. So when you think about the combination of data scientists and user researchers, it's kind of like looking at the whole picture. Oftentimes, we are distributed in different teams, and we only see one very small part of the big picture, right? And we have our own assumptions that we create, our own hypothesis. But working together with interdisciplinary teams actually helps us look at that bigger picture and understand what is it that the users want. I really like this comic because the dentist says, why does my rating drop after a root canal? Because the dentist is only looking at the numbers, right, the quant. And probably the nurse, I guess, says, well, doc, of course, root canal is very, very painful. Have you tried to ask the users how they feel? Nobody likes getting a root canal, right? It's always painful. So both look at the world very differently, different new perspectives, right? Different ways of thinking, different methodologies. But combining the two gives you that holistic understanding, that bigger picture, and not just in terms of the perspectives and thinking, but also in terms of the data sources that they gather. It's also great for keeping biases in check, because the more methods and the more data sources that you employ, you're hopefully able to mitigate the biases that would have come from just using one particular method. And honestly, it's just a really good way of blending people and data together so that you can understand what exactly is it that the users want and getting closer to the truth. All data is created by people, and all people create data. Today, we divorce people from their data, and that gives companies license to forget about the people behind the data. It allows us to divorce ourselves from the responsibility of what that data can do. And I'm guilty of this as a data scientist. Just staring at numbers all day, I forget that there are actually people like you and me who's generating that data, right? There are people behind that data, living human beings. And we might just think of our app or our software as a product, but that's actually making someone's life better, or maybe making someone more frustrated. We don't really think about the users as much. Which is why any talk about users, about user research, about development, data science is absolutely incomplete without talking about ethics. And this is getting even more relevant as we enter into this whole age of AI and LLMs and just using whatever data we can grab our hands on. So as developers, or as any person who creates a product or creates software for someone else, make sure that you're thinking about these questions. Understand how the app or the product you're developing can be attacked or misused. There have been cases where your home automation devices like Alexa can actually be used to eavesdrop into conversations. They had this feature of calling Alexa, and for some reason, the Alexa would not actually alert the users and would just silently pick up the call and could hear whatever conversation was happening. Unfortunately, it was used for cases of gaslighting and domestic abuse. Make sure that the training data you have is fair and representative. I think Scott mentioned this in his keynote. It's happened with me personally. Oftentimes, if you go towards those motion sensors or those, basins that are automated, I have to wave my hands multiple times. And why? Because the training data that was used to create these models were very biased. They were only trained on a certain demographic and weren't really diversified or generalized enough. Another example was anyone here named Jared? Anyone? Okay, no one, right? Too bad for us, because there was this company that created this automated resume reviewer, which would take all of the job candidates' resumes and then see who should be passed on to the next round, who should move ahead. So this company created this, and turns out that the #1 quality of resumes that would actually guarantee if you get an interview and hopefully a job was if this person was named Jared. Anybody named Jared, irrespective of your background, your educational qualities, your experience, you would absolutely get the interview, no matter what the job. Okay, that's bias in play, and that's scary. Very similar to this, they actually had models where anything that would mention the word women in the resumes would immediately give you a less likelihood. So if you participated, for instance, in women's debate clubs or women's sports varsity teams, it would actually be negative likelihood for you. Again, bias, because they've trained it based on the people that already work at that company, which unfortunately was filled with a lot of men. So accordingly, study and understand what are the possible sources of bias that could be creeping in. Make sure that you have a diverse team that's diverse not just in terms of thoughts, backgrounds, but also perspectives, opinions. Of course, the data that you collect needs to have explicit consent coming in from the users, right? We're seeing a lot of copyright cases happening with Stability and ChatGPT because the users, the authors, the image creators didn't really consent to their data being scraped. And make sure that even though your system is fair today, will it continue to stay fair tomorrow, 10 days out, 10 months out, 10 years out? Possibly not, right? There's a lot of things that change, that happen over time. How do you ensure that it continues to stay fair throughout the life cycle? Ultimately, make sure that you have a way to shut it down in production if something goes wrong and to redress those harmed. Anyone here familiar with Microsoft's Tay chatbot? So Tay was this chatbot that Microsoft put out on Twitter, which was supposed to learn from the tweets that people would tweet at it. Less than 24 hours, less than a day, it had to be taken down because it turned homophobic and racist. Because unfortunately, all the people on Twitter were doing that. They were throwing all sort of racist abuses at it, homophobic slurs at it, and that's what the model learned on, because there was that feedback loop. And that's what talks about us as a society. 24 hours. That's all the chatbot lasted. Fairness, accountability, and transparency is really, really important. And I like this example of, well, if your dog poops and you have a Roomba and the Roomba spreads the poop everywhere, who is to blame? Is it the dog? The dog was doing its job. Is it the Roomba? The Roomba was also doing its job. So who is to be held accountable? Also, this is a true story. There are pictures on Reddit. If you're really, really curious, I wouldn't advise, but if you're curious, go ahead. All right, so far we talked about user research. We got an understanding of what it is that user researchers do, what are some of the methods they employ. We took a look at the data science pipeline. What is it that data scientists do? We understood that they have very different perspectives from the qualitative and quantitative aspect, and saw some case studies of how to combine the two and get some successes for our users, which is all great. But you're here at a conference, and I hope that you don't think of me and my talk as just something hopefully nice or interesting to think about. But I want to leave you with something actionable that you can take. Here's what you can do. Care about your users and talk to them, no matter what role you are in. Find a client-facing team. Tell them, hey, I'm interested. Can I listen in on the conversation? Are there any data points that I could take a look at? Be proactive about that. There is really no substitute for that. Find data scientists or user researchers in your company. Talk to them. What is something cool they are working on? Are there any issues that you're noticing in your part of the org? Tell them about it. Maybe they've heard about it and they can help. Or maybe it's completely new to them and that could actually kickstart a new initiative. And of course, I've heard that some cases, there are some cases where people don't always have data scientists and user researchers in their company. That's okay. Go out, network. You're at a conference over here. Talk to other data scientists. Talk to other user researchers. Get an understanding, right? Because that just expands your horizon. Discuss the pain points that you're noticing in the software. Are there things that users are complaining about? Are there a lot of tickets getting filed for a particular issue? Is there a new feature that users have been asking about, have been demanding for a very long time? Share that knowledge with them and see what they tell you. Ultimately, start small when you do this interdisciplinary connection. Start small, take baby steps. Maybe even create prototypes. Don't wait for permission. If something looks good, if something succeeds, great. go ahead to your stakeholders, to your executive, get buy-in from them, and see how you could scale up that initiative. And make sure that you quickly iterate on projects. Don't wait for it to be perfect. Make sure that you have something there, even if it's a marginal improvement. And see how you can use data as evidence, whether that's data coming in the form of feedback from users, in the form of instrumentation from your products, or any other metric that you might deal with. At the end of the day, this is the question we want to answer. This is us, and those are our users. What do our users want? And our users are going to be confused. Our users are going to be messy. There's also this concept of introspective illusion, where users think what they want, think they know what they want, but they actually do the completely opposite thing, right? So make sure you always have your pulse on what your users are looking for. They are the ones who are going to make or break your product. They are the ones who are going to make sure that your company, your product, your app succeeds. And ultimately, we all love those sweet paychecks, right? We want to be successful. We want our companies to have a good name in the industry, to deliver good products. Here's a list of resources if you'd like to continue reading more about data science and user research. After lunch, I am doing a 2-hour workshop on Intro to Natural Language Processing with Python, which is going to dive deeper into the data science aspect of it. So if you're interested, highly recommend you to come and join. And last but not the least, it was really nice having you all. Appreciate the audience participation as always. If you could give me any feedback on the talk, I would really appreciate that. Always looking to improve. If you're interested, you can go ahead and enter your email if you want a list of the resources that I just shared on the previous slides. If not, that's fine. It's completely optional. And here are ways to contact and reach out to me. I hope you learned something new today. I hope you can go back to your teams and share something interesting with them, even if it was a case study or some new phrase or technique that you learned about. And thank you so much again for your time and attention.